Hi and welcome back. In this video we're going to work on completing the square. Specifically we're going to be looking at two topics. The first is completing the square at its most basic level, and then we're going to move into solving quadratic equations by completing the square. So let's take a look at our first example. So for our first example, suppose we have the expression x squared plus 6x and we're asked to complete the square. That is, add on a third value, a c value, some constant, such that we can eventually factor this thing into an expression that looks of the form x plus a number squared. So how do we do this? It's really quite simple. All we have to do is take our middle term, 6 in this case, which is normally our b term. 6, we say c is equal to our b term, 6 over 2 squared. So we have c equals 3 squared, which is 9. The general form of this expression is c equals b over 2 squared. Remember, this a, b, c, these values come from the standard expression, the standard form of a quadratic, ax squared plus bx plus c. So we take the b values divided by 2 squared. That'll be equal to our c value. Now, what do we do with this c value? All we have to do is plug it in, and we get x squared plus 6x plus 9. So, how is this useful? Well, I know this splits apart into the following expressions: x plus 3, x plus 3. This 3 should look familiar. It's the inside of this equation that we used. Compacting this a little bit, I can put this into the expression x plus 3 squared. And there you have it. That is completing the square. Let's go ahead and take a look at another example. For our next example, let's say we have a squared plus 12a, and then we need to add on some c value to complete the square. Well, our b value is 12, so I say the c value that I'm going to add in is equal to 12 over 2 squared. Well, that's equal to 6 squared, and that gives us 36. So I'm going to finish up my expression, and I get a squared plus 12a plus 36. This splits up nicely into a plus 6, a plus 6. Compact those values, a plus 6, the quantity squared. And that's it. I'm going to show you one more example and how you can jump ahead and not have to write these steps. For our final example, let's say we have x squared plus 13x, and we're supposed to complete the square by adding on a c value so that we can write a fully factored form. Now again, let's take note that our b value is 13, so c is equal to 13 over 2 squared. As I mentioned before, this 13 over 2 is a useful value. Well, all I have to do is plug it in here, square my quantity, and I'm done. It really is that simple. Next, let's see how we can use this completing the square technique in our quadratic equations. Suppose we have the example a squared plus 14a minus 51 equals 0. The first step in this process to complete the square is to move our constant to the other side. There are some techniques that involve pulling apart our constant and taking advantage of its value to complete the square, but that can get a little messy if you're not familiar with the process. So it's best just to move it to the other side for the time being. So notice that on the left side we have the start of a quadratic expression. We have a squared plus 14a. It'd be nice if we had a c value that we could add in here so that we could complete the square. And that's going to be equal to 51. So what is that c value? So c, if you recall, is equal to b over 2 squared. b in this case is 14 divided by 2 squared, so that's 7 squared, or 49. So I'm going to place 49 here, and since this is now an equation, if I add 49 to the left side, I have to add it to the right side. I'm going to go ahead and factor this. Now remember, I completed the square, so it's a nice, easy factor. 7. 7 is 14 over 2. So that is now equal to 51 plus 49, which is 100. I can now take the square root of the left side and the right side. Since I'm taking the square root of the right side, I have to add in my plus minus. And I'm left with a plus 7 equals plus minus 10. The only step left is to split this apart and solve both equations. A plus 7 equals positive 10. A plus 7 equals negative 10. So I have a equals 3 and a equals negative 17. Let's go ahead and take a look at another example. Next up, we have r squared minus 4r minus 91 equals 7. As we did in the last example, I'm going to go ahead and move my constant attached to the quadratic to the other side of the equal sign. So I'm going to push 91 to the right, and I have r squared minus 4r equals 98. So I have a nice little quadratic expression here that I'm going to go ahead and complete the square on. So I'm going to add some value to it, and as we did in the previous example, I'm going to add some value to the right side to keep it balanced. So looking at the left, I have r squared minus 4r plus some number. Minus 4 is my b value. So c equals b minus 4 over 2 squared. That's negative 2 squared, or 4. So I add in 4, and then I add 4 to the other side. Here, I can take note, because of this negative, that it's going to equal r minus 2 quantity squared, and that's equal to 102. Last step, take the square root of both sides, plus minus on the constant, and I get r minus 2 equals plus minus square root of 102. I'm not going to worry about the radical in this equation, so I'm just going to go ahead and move 2 to the other side, and I get 2 plus minus square root of 102. Done. Let's go ahead and take a look at one more example. Only in this case, the r squared, the quadratic term, is going to have a leading coefficient. Suppose we have 8x squared plus 16x equals 42. Now we have to be careful here. The only way completing the square works is if our leading coefficient on the quadratic variable is 1. To do that, we have to divide everything by the leading coefficient to clear away that value. So I'm going to be left with x squared plus 2x equals 42 over 8. That's 21 over 4. And I'm just going to leave it like that for now. So you see on the left, I have my quadratic expression. It's almost set up to complete the square. So that's x squared plus 2x plus some term equals 21 over 4 plus that term we're going to add in to complete the square. And that value is, from our c equals b over 2 squared, b is equal to 2 in this expression. So c equals 2 over 2 squared. That's 1 squared, that's 1. So we're going to add 1 to both sides. So here we have a nice factorable expression, x plus 1 squared. And that's equal to 21 over 4 plus 4 over 4. So I'm just going to rewrite that real quick. X plus 1 squared equals 25 over 4. Take the square root of both sides, plus minus over here, and we have x plus 1 equals plus minus 5 over 2. So we now have two expressions to solve. X plus 1 equals positive 5 over 2, and x plus 1 equals negative 5 over 2. If I subtract 1, that's x equals 3 over 2, and if I subtract 1 on this one, I have x equals negative 7 over 2. And that's it. Let me know if you have any questions on these, or if you'd like to see any other examples like this.